Hello and welcome. So the goal for this video is to create an automatic cat feeder. If you have cats, you know the struggle of waking up at 5 a.m. to feed them.
No, no, no.
And I mean, they're on the right to wake you up early. But sometimes I don't want to get up early. So I'm trying to make an automatic cat feeder which will keep him on a regular feeding cycle and also produces the right amount of food an adult cat should.
Why?
I design everything and 3D printed a lot of the parts,
Is this too little?
and I also had to get some things from Amazon, like this pinion gear, this NEMA 17 motor. It's a small motor, but it has high torque and it packs a punch. For the brains, I'm using a Big Tech TMC 2209 stepper motor driver, and I'm controlling the with the Arduino Uno R3. I just had it lying around. This is not the final electronic configuration, but this is my test configuration. I also picked up this set of screws and nuts. They vary from M3 to M5, different sizes, washers and nuts. Also, I use this ball bearing. It's not completely necessary. It will work without the ball bearing, but this increases the lifespan of the bearing holder. If not, it will just rip away eventually. This is version 1, so I had to test the fit, make sure all the parts will fit together, and I didn't need to redesign anything. The auger was the hardest thing to print. It took me several times, and I also learned the word auger. It's the screw feeder that rotates, intakes and outtakes the food. With everything seemingly fitting together, it's time to secure it in place. As you can tell, this design was designed with modularity in mind, so it has a lot of extra holes where you can attach different feeders, different funnels, just different things, whatever fits your needs. The only thing that's not particular modular, it's the motor holder. I was gonna make it modular, but for a more precise fit, I made it exactly what I needed for this configuration of motor and gears. I'm using a 2-to-1 gear ratio to double the torque at the cost of some speed, but I don't need this thing to go fast. I need it to be reliable and accurate. The screws I'm only using it's the M4, except for the motor. The motor requires M3 to be secure in place. With everything put together, it was the moment of truth. Time to plug it in and see if it runs. Really exciting. Everything was working perfectly. My biggest concern was the way the pinion gear and the drive gear will fit, but it seems like I nailed the distance. So I ran them for about 10 minutes to see if nothing will break, but everything ran great at a constant speed. After the 10 minutes, I checked a little bit the thermals of the motor and the motor driver. No magic smoke. And it was time for the first feed test. Nothing getting stuck. After this test, I went and designed the funnel and the electronics box holder. Of course, one of my kitties had to see an action. This is Soka. He's the one that needs to approve my design, and so far he's liking it. Again, nothing getting hot. So then it was time to attach the funnel and the electronics box. This is the look of the more complete final configuration of version 1, of course. I'm using relative large boards, but for a future build I will probably could reduce the size of the electronics box, but it's also good to have big to add other electronics as needed. Time for the real test, adding a large amount of food and see if anything will get stuck.
No, no, no.
Everything was working fine and great.
I'm doing science, guys. I'm doing science.
I was getting the right amount of
Right.
food.
Look, is this too little?
But then disaster struck. So I don't know if you noticed, but there was a flat face inside the shell of the auger, and food was getting stuck there. As you could hear this loud stuttering. I was devastated, but it was version 1, so time to go back to the drawing board, redesign some things, and come back with a better design.